Hello students, what is going on? मैं Abdullah Momin, KMES English Medium High School and Junior College, and in this video we are going to learn about phase in SHM, and this is your lecture number 5 from the chapter oscillation. So what is phase in SHM? So phase is defined as the state of oscillation of a particle is called phase. So basically the meaning of phase is state of oscillation. And in order to describe the phase at a place, we need to know three things. First, the displacement means position of a particle. Second, the direction of velocity. And third, the oscillation number. So if we know the displacement, direction of velocity and oscillation number, then we can easily describe the phase. And we have the equation of displacement of a particle performing SHM as x is equal to a sine omega t plus phi, and this is the displacement of SHM, and in this equation this bracketed term, that is omega t plus phi, is nothing but phase of SHM. So let us understand this phase, that is omega t plus phi. So relation between circular motion, uniform circular motion, that is UCM, and simple harmonic motion. So in order to understand the phase, first we will understand what is the relation between uniform circular motion and simple harmonic motion. So suppose a particle is performing a uniform circular motion on the circumference of this circle, and the image of this particle we are going to make on this blue line, and on this blue line the particle will perform the SHM. So let us assume that initially the particle is at position P naught. On this circle the particle is present over here. So first we will draw the perpendicular from point P to this blue line. So we will say that on this blue line the image is somewhat here. Now the after time t the particle move to point P, that is this, and the image of this particle will be at this point. So when particle moves from P naught to P on the circumference of this circle, so in this line particle has moved in upward direction, or we will say that in positive direction. And the initially the particle is at P naught, and the angle is made by with the horizontal is phi, that is called as initial angle or initial phase. And after time t the angle covered by this is omega t. So total angle covered in time t is initial angle plus angle covered in time t, that is phi plus omega t, or omega t plus phi is the total angle covered by this particle from the horizontal. And this angular displacement, that means theta is equal to omega t plus phi, is the phase of SHM, and it is also called as the phase angle. So if a particle is performing uniform circular motion on the circumference of this circle, it is performing SHM on this line. So the angular displacement, that is theta is equal to omega t plus phi, is the phase of SHM. Now when a particle starts from point A, at this point the angular position is 0. So the angle made with the horizontal, that is the angle made with the line OA, is 0. And the particle is situated at this point on this blue line, and we will say that this is the mean position. Now at point B, the angular position is 90 degree when the particle is present at point P. So the angle made with horizontal is 90 degree, or in radian we will write pi by 2 radian. Now particle starts continue its motion and it reaches to point C. So now the total angle made by this particle with the horizontal line OA is 180 degree or pi radian. Next, when particle moves to point D, the angular position is 270 degree with this line OA, this 90 plus 90 and this 90 total angle covered by this particle while moving from point A to point D is 270 degree or in radian is this 3 pi by 2 radian. So the image of that particle will be somewhat here. So when it completes one oscillation, if it comes to point A again, it will be 360 degree or 2 pi and not 0. So particle starts from a completed one round and again come back to point A. So the total angle covered during one revolution is 360 degree or 2 pi radian. Means the particle started from mean position, goes in upward direction, then comes back to the mean position, then continue its motion to downward direction, and then it will return back to mean position. So this is one oscillation. So when particle completes one revolution in circle, on this circumference of the circle, it completed one oscillation on this line. So we are going to see four special cases when phase theta is equal to 0. That means at point P, phi is 0. At point A, phi is 0. Particle is situated at point A and its image will be at mean position. So the angle covered. Now particle didn't start its motion yet, means the time is 0 and this value of phi is also 0. So total angle covered is 0. When you will put the value of t 0 and phi 0, we will get theta 0. Theta is 0 means phase is 0. So we will say that the particle is at mean position moving to the positive direction. Particle is at mean position and moving towards the positive direction after one oscillation. When it completes one oscillation means one revolution, its phase angle changes by 360 degree or 2 pi radian. So after time t, the angle covered is 360 degree and the initially it is making the angle 0. So we'll say that phase is 360 degree or 2 pi radian. Next special case is phase is 180 degree or pi radian. So at point C, the angle phi is 180 degree or pi radian. Suppose the particle is at point C. So it is making an angle with this horizontal line OA and that angle is 180 degree means pi radian. And the image will be again at mean position. And we know that phase is theta is equal to omega t plus phi. So at time t0, now we are going to put the value of t as 0 and the value of phi as 180. So we will get theta is 180 or pi radian. So the particle is at mean position and moving to the negative direction. Now after one oscillation, phase angle changes by 360 degree or 2 pi. So we will write after time t, the angle covered, that means omega t is 360 degree and initially it is making angle 180 degree. That means 2 pi radian plus pi radian. So the total angle will be, total phase will be 3 pi radian. Case 3, when the phase angle, that means theta is 90 degree or pi by 2 radian. So at point B, phi is 90 degree or pi by 2 radian. Now the particle is situated at point P and the angle is, initially it is making an angle with this line OA is 90 and the image from point P will be at extreme position. So we will say that at time t the phase is 90 degree or pi by 2 radian. So the particle is extreme position and moving to the negative direction. It is going to move in downward direction. So after one oscillation, the phase angle changes by 360 degree or 2 pi radian. Now the total angle is 360 plus 90. That means 2 pi plus pi by 2. And this is the phase angle. This is the initial angle made by the particle, and this angle is covered after one oscillation. Now the fourth case is when the phase is 270 degree or 3 pi by 2 radian. That means the particle is at point P, sorry D. If the particle is at point D, so the angle is making, the angle made by this particle with this line O is 90 plus 90 plus 90, that means 270, and the image of that particle will be at extreme position. So the phase angle is theta is equal to omega t plus phi. So at time t0, the phase is 270. Means in place of t we are going to put 0, but in place of phi we will put 270. So we will get theta as 270. And we will say the particle is at extreme position moving to the positive direction. Means it is moving in upward direction. So after one oscillation, the phase angle changes by 360 degree or 2 pi radian. That means theta is 360 degree plus 270 degree. That means in radian, theta is 2 pi radian plus 3 pi by 2 radian. This is the phase when the particle started from point D and completed one oscillation. So that's it, student. Thank you very much. I will catch you next time.